Late in the year of 1843, a beer brewer will make a small discovery that will change the laws of science forever. This beer brewer further expounded energy. Prior to this date, however, heat was considered a fluid called caloric. Caloric was self-repelling and diffused from high concentration to low concentration, also known as high heat, low heat. For example, if you were to leave a metal spoon into a boiling pot of water, the end of the spoon, which is not even touching the water, will gain caloric and thus becoming hot. It was also believed at the time that heat can neither be created nor destroyed. This was disapproved when an American physicist managed to boil water after continuously boring a cannon for 2.5 hours. He then stated that heat was excited by friction. However, 60 years after this theory gained its ground in popularity, a privately taught physicist by the name of James Prescott Joule that beer brewer I was telling you about will revolutionize our understanding of energy. So what exactly did he do? Throughout history, links between forms of energy have been shown. Gravitational to kinetic, kinetic to elastic, mechanical energy to another mechanical energy is self-explanatory. However, when heat is introduced, it is an entirely different animal. It was understood that strength of mechanical energy was decreased due to some of it transforming into thermal energy. But what is the equivalence of mechanical energy to this heat energy? This is what James Joule set off to discover. Using what is now known as Joule's apparatus, James Joule had a weight attached to a string. With that string wrapped around the paddle, as the weight falls, it unwinds from the paddle, making it churn water. What Joule did is measure the temperature increase of the water before and after the weight falls. Let's say we have a single gram of water. If we were to raise the temperature of this by 1 degree Celsius, it would have taken exactly 1 calorie of heat energy. If we were to raise a kilogram of water by 1 degree Celsius, it would have taken 1 kilocalorie of heat energy. The energy put into this system is equivalent to the gravitational energy of the raised masses, twice the value of 1, 2 mgh. Then multiply this value by the number of times the masses were dropped to get the total amount of work put in. If we divide this work by the amount of kilocalories of the water, which would just be 1 because James Joule stopped once a kilogram of water increased by 1 degree Celsius, we then get the following constant. 1 calorie is the same amount of energy as 4.1860 kilogram meter squared per second squared. This unit of energy was then labeled Joule. A few years later, this was a crucial step in leading Julius Robert Mayer to discover the law of conservation of energy, the first law of thermodynamics. These laws of thermodynamics control the interactions of everything in the universe and span across every field of science known by humankind.